Good afternoon, everyone. My name is Ivan Kolodilin. I'm your new computer science and programming teacher. Firstly, before you were learning Python language, and now you will learn C# language. Very sorry that you didn't have a computer science course for a long time, but now we will start it again. If you have any questions before the lecture, before we start, you can ask them.
I'm sorry, but we didn't complete our course of Python with that. I didn't remember what to say, but how we will start C sharp.
We just decided
Who decided?
I'll show you the course. Wait, I'll share my screen.
ما تقول بالعربي انت مكسوف منه ولا ايه؟
Okay, here is your previous course on Python, right?
Yes.
You previously had lectures and some practical lessons. You submitted some your assignments. They will be estimated. In this similar course below, you can see that lectures on C# course and also practical lessons on C# course.
Yes, I understood. I'm sorry, but I'm asking who decided that we will end our Python, we didn't complete it, and start a new programming language C sharp.
It's okay because you will have
You
Python.
decided?
Yes, I got your point. Don't worry about Python course. You will have it in another subject, but also as a mechatronics students, it's also important for you to study a C# course. Do you
I'm
understand
sorry,
it?
but do you know that this part of Python with our meta-analysis now, they complete each other to have one course about the how can I say it? اسمها إيه يا اسطى؟ data analysis.
And what? What are your questions?
And what I will do with this C sharp.
Uh, repeat the question again.
What I will do with this C sharp. Why I study it. At least I study for C or C++, maybe, but what I will do with C sharp.
I'll show you on a lecture what you can do with the C#. So you don't see the reason for studying C#.
I don't know why should I study it.
I'll show you on a lecture.
And what about the Python?
Excuse me?
What about the Python?
You will have it on another course with another teacher. And in this course,
أسأله أنا كده. Excuse me, I have a question.
and before end of this year, we will start C# course.
I have a question about we didn't finish Python course until now. How we can study another language now?
We will start from the beginning, so don't worry about it. Everything
I
will
think
be clear.
for Python we just study for beginning for Python, and my friend say now we didn't understand anything from the mathematics in Python, and we just study the while loop and else and like this, and we didn't study anything more. And the C sharp, it's very difficult. How we can start another language and we don't start. We don't understand. I don't understand the Python until now, and all my friends like me.
You were studying Python for 3 semesters, right?
Yes. I started Python one semester before, and I think this semester, and I don't understand this semester, and I think I understand something from one semester from the first. All the students like me, not just yeah.
So now we will study C#. Okay.
So can you please explain to me what we will take in C sharp before we start?
What we will take what?
What we will take in C sharp before we start? Just explain, like how it related to our mechatronics.
Okay, let me show you my
Okay.
paper. This is the first paper I wrote, and simulation environment can be really helpful for simulating things related to mechatronics, such as conveyors, industrial robots. You can do the same in MATLAB, but MATLAB not really suited for virtual operations. For example, there is a robotics toolbox, as you can see in the middle of the picture. You can manipulate with the robot by this simple structure, but it's not really exciting, not really interesting. So you can model the same stuff inside the Unity with C#. And then instead of this simple software, you can work with the more complex things and do the things you can do inside the MATLAB, for example, sorting cubes. In this software, I connected the Unity program and MATLAB. So from the Unity, I transfer data to the MATLAB, like I depict color of the cube and then sort them by MATLAB. So to the MATLAB, I send pick color of the cube, and to the Unity back, I sent coordinates of the robot, so I can sort cubes. Another simulation environment I developed is related to the mobile robot navigation. Sometimes before going to the practical approach, it's really convenient to simulate the things. For example, here I simulated the mobile robot, laser, which you can project on walls, and camera. Here it's different type of camera, like GoPro camera, which has a really wide field of view. And the benefit of creating simulation environments that you can estimate parameters which you cannot estimate in real cases, like orientation of camera. You cannot estimate it in real cases, but inside the virtual environment, it's known. For example, really easy estimate pitch, roll, yaw. Also, as for mobile robot, in real cases, it's difficult to estimate its location. For example, GPS won't work inside the indoor environment, or encoder may suffer from noise. And inside the virtual environment, everything is known, so it's really convenient to compare methods between each other. Also, as you can see, it's really pretty similar to real cases. So once you tested your method inside the virtual environment, you can move to the real cases. So first of all, I tested inside the virtual environment, and then I proved that my theory is working inside the real cases. So here you can see also a map, and I obtained map. So I calibrated systems and obtained the right map. So these kind of things you can simulate with the C# and Unity. So did you get the point?
No, okay.
So do you think it will be helpful for you or not? So any other questions? You can go ahead.
Yes, excuse me. I have a question about I know about the re-exams that we have tomorrow, because
Yes.
for the first semester there are PDF files for us to study from, and there is an example for the exam. There is like a pre-exam that we can try in it before the exam, but in the second semester we don't know from where how will the exam look like, and what should we study for the exam, because there are only lectures and we didn't understand a lot from the last professor, because she wasn't explaining a lot. She was only giving us practical lectures, and she told us to use only Google Colab, and we didn't understand anything.
Wait, I will open that course. Should be this one. So here's a final test example, okay, for the second semester. And here's the exam you will take tomorrow. So exam is similar to what you had before. So first of all, you connect to this link. I'll tell you the procedure and then code of the exam, and then you will take the exam. Questions will be similar to what you had before. You will have 45 minutes, 40 points in total, and you need to take 20 points in order to pass the exam. Then students who...
Excuse me, sir. I have a
Yes.
question.
Yeah.
So tomorrow our exam question pattern will be like this or similar
Yeah.
similar exam.
Yeah.
Oh, okay.
First of all, it will be depth for the second semester, and then we'll move to the first semester.
So tomorrow we'll have the second semester exam first, and then after that the first semester, right?
Yes.
And it will be all online
Yes.
on Google Meet.
Yes. This link.
Okay, thank you.
Excuse me, sir. I have a question about the pending assignments of this semester. Like, we had a lot of assignments for Python. Does it matter till the end, and can we submit if we are late for submission?
Yeah. If you have any assignments, you submit them, and then we sum all of the marks from your Python course, C# course, and you will get the final mark.
Thank you. I will submit then from Python.
Yeah. Any other questions? If there's no more questions, let's start our lecture. My name is Ivan Holodilin, and let's start introduction to C# and Unity. I already shown you what can we do in scientific course, how can we model simulation environment, what we can do with that, and let's see, most commonly Unity is used for video games, and so let's start how it can be used in video games. First of all, you will need to install the Unity itself before the practical class. On lecture, I will just show you.
Sorry for being late.
So in order to download the Unity, you need to click this link and download the Unity Hub by clicking this button. I already have it, so I won't install it and show you what does it have. The Unity Hub itself, it's like shows organization of your projects, and from here you can create new project or add one from your computer, and with different versions of Unity. First of all, you need to install a new version of Unity. You can install it by clicking Add button, and here you will see a recommended release, which is selected by default, official releases, which you also can install, and pre-releases, which is not really recommended to install because maybe some bugs there or some logs, so don't try to install this one. You can just simply select this version and click next. it is really important to install a Microsoft Visual Studio because all of the programming is taking place there. Unity just visualization, and here we program the things. So it's also important for you to install Visual Studio as well. And below you can see different other packages. For example, if you want to build games for mobile phones, you can select Android build support, or if you want to build for iPhones, you can select iOS. And below listed also laptops if you want to build your game for Linux, Mac, or Windows. Here you can just leave default setting. We won't need them. So here you can click next and Unity will be installed. About new project. We will work with the GitHub. The benefit of the GitHub is that you can get access to your project from different laptops. You can change your project on one and then open change on another. Also, you can work, also several people can work on your project by using GitHub. So you will need to register a GitHub account. Once you registered it, we will create a new repository. On lectures, I will just show you the things we will do on practical classes. On practical classes, we will do the same things together. So you just need to prepare software before the practical class. And then we will do the same things I described you on lecture. First of all, we need to give it a name. Let's write demo. Description optional, and you can make your repository public or private. If it's private, only you will see it, and if it's public, everyone can see it. We will add a README file, and we will add a git ignore file. What does it mean? I'll show you later. It's really important to add this file. And here we will choose Unity. And next, create a repository. In order to get access to this repository, we need to download another program. You can download this project from here, but there is another more convenient way to do it. For this procedure, we need to download work program. This is also for free. You can download it for Windows or for Mac. And what does the fork mean? I already installed it, so I just show you how to use it. We need to copy the link, and then we will open it in fork by clicking File, Clone, and it's already copied. And then we choose location where our project is located and its name, and click Clone. Now we have it on our computer. Next, we create a Unity project itself. Here we click New, select location, what we've just created, and give it a name. And click Create. Then we need to wait for some time. While it's loading, I'll show you your homework for today. So before practical class, you need to install Unity, any version, personal or student, and Visual Studio. Also create a GitHub account and install fork. and then we will work with that software on a practical class. Tomorrow is your exam, so the practical class for you will be on the next week. So while project is creating, you can see that it's created a folder. I'll show you the folder. This one, and it has this number of files in total. And we can upload all of these files to our project created online. But it will be difficult to upload all of these files because it's really a huge amount of files. And exactly for this procedure, we created previously this git ignore file. But now it's located in a wrong location. We need to place it to the folder with the Unity. So if we will place it, move it here to the right location, our number of files will significantly decrease. And it's really easy to upload these files. Instead of 7,000, just 30. So that's the reason for creating a git ignore file. It will write only most important files and eliminate not necessary files. Then we, in order to upload project online, to get access to other users or to get access from another laptop, we need to click Stage. Check all of the changes. Then we write commit. We can just describe what we've just done, created project, for example. And commit these 27 files. So they're here. Then we can click push and our files will be uploaded. Then we need to wait some time and they will be appeared here. Okay, as you can see, they appeared here. At the same time, we can make changes online and then download them. For example, if we in README file write our first program, and commit changes, we can also, we will need to click pull button in order to download them. We click pull and README file will be updated. As you can see, we updated README file. Now let's move to the Unity project. First of all, about its layout. It can be switched between any modes you like, but I'll show the layout I'm using. I'm using my own, which I really I'm using this one. It is a scene where we can locate some objects, attach script to them. For example, if I create any cube, We can do some modification, move it, rotate, and so on. And next window is game mode. Here we'll see what behavior our cube will have if we attach any script to it. For example, here our folders. Let's here create folder with the name scripts and create our new script by creating C# script. And open it. We'll wait for some time and then Visual Studio will be opened. And here C# creating classes for us. For example, we just created class test script, and inside this class we can operate, and we can't go out of these brackets. For example, if you write any code here, it won't work. So we need to work exactly inside these brackets. And in the above, you can see some namespaces. In other words, this is our libraries. For example, if we want to work with some buttons or other user interface, we need to connect corresponding library. As for example, for buttons, it will be Unity Engine .ui. And after that, we can work with buttons. As you can see, it's not highlighted because we don't use any button script in our project. And inside some events function, here the most frequent use, void start and void update. Void start, it's called once we launch our program by clicking this button. It will be initialized only once, and the update function will work simultaneously. For example, if I print something inside the console, for example, test, we'll print test. Inside the start, we'll save it, move inside the Unity. Here's the console, here it will be written test. If you don't have a panel console, you can activate it by open window and then selecting console general, and here it is, console. So if we run it, we will see how test will be printed here. Now we run it and we don't see test here. Why? Because we didn't attach our script to any object on the scene. How to attach the script? You can simply drag and drop it to the object cube and it will appear here. Another way of attaching it is like you can create any object, add component, right here script, and choose your script. So as we attach it to the object, now we will see in console test will be printed. So here we go, test. And it was printed only once as we place it inside the start. And if you will move it, this function inside the update, it will be called repeatedly again and again. So we saved it we go here, and now you'll see that it appears here again and again simultaneously. So in this way, we can read some data from the sensors or move any object, this idea. Next, let's consider some variables. If you want to work with the variables, you need to define them before the start function. In Unity, we can work with, for example, integer numbers, int a equal to 5. Also with float numbers, float b equal to 5.1. And here with the float data, it's really important to write f in the end. It's float data. Also, characters rc equal to this break. String data name, for example. The difference between characters and strings that for characters it's only one letter, and for string data we can use words. So then we can use these variables instead of manual printing. For example, if we write b here, it will be highlighted, so we use it. Then in update, we'll print 5.1. Let's see how it looks like. We move to the Unity. Click play button, and here it will be 5.1. Also, we can add some description to it. Okay, any questions?
Will you open this? Will you upload this record after the lecture?
Excuse me?
Will you upload this record of the lecture?
Yes, we're recording lecture.
Yes, you will upload this record. Yes.
Yeah.
Okay. Thanks.
So print. Yeah, we print number. And plus. So in order to provide any description, we write number is our description, and in order to combine this description with the number, we need to add plus sign. So we saved it, go to the Unity again, and here we will see number 5.1. We can also create our custom functions by different ways. For example, let's return some value. We create function int double brackets. Here you can see it's highlighted because we can't use name double. It's already occupied by C#, so we need to provide some additional name of our function. Double number. And wait. Here we return some value. Okay. So we can use double number, but we can't use double. It will be highlighted. It's already occupied by some libraries. So double number is okay. I'll describe what does it mean later. First of all, we need to call this function from, for example, from update. And let's comment this out. For a single line code, you can use these lines for commenting something out. And if you need to comment several lines code, you can use this type of comments. And here you can write something in several lines to explain your code, for example. And how to call this function, we need to, also write int. Double. So what we've created here, we created a function which will return us a doubled number. Here we have a, it's 5, and we will return a multiplied by 2. So we will return 10 inside this function. We are working with integer numbers, so we write int here. And in order to store this returned value, we created a new variable int AA, and the number 10, this number will be placed inside the AA. So we call this function, we get 10, a multiplied by 2, it will be inside AA, and we print it. So let's see the code itself, how will it work at the Unity. Now we will see 10 here. Okay, it's printing 10. Let me show you what else we can do. Currently, we just work with the variables inside the script, but we can move further and get access to these variables inside the script by making this variable public. For example, we create public variable and save it, move to the Unity, and we will see this public variable here. By default, it's 5, as we defined here as 5, but we can change it now inside the Unity. So we don't need to go to the script directly. It can be modified from the scene itself. Is 10 if we change it. 16 multiplied by 2, so now it's 32. So it's more convenient to work from here than change it in the script again and again. Another way of defining and calling function by using these brackets. For example, we can define new variable here, int variable, and then we use this variable. And here we also need to provide some data to it. For example, our A, and this A. So what we just wrote, we give this A number, which is nothing but here, to the function. So 5 will be moved to the double number, and then we move this A to this function, int var. what's inside brackets will be here inside the brackets. And it will be also multiplied by 2. So it's a similar things, but just written in another way. So let's launch our code. Oh, we change it here, 10, now it's 20. It's 5, now it's 10, and it's 2, it will be 4. Okay, code is also working. And we can also call functions from different way. It's not necessary to return value. We can call function from this update or start cycles. So we can create a new void. Let's create void my name. And here will be provided a string data. String name. And we will print in console print I'm pass name. And let's, for example, create new public variable, public name, public string name. New name. And call function. We need to write name of the function which we are calling and provide a new name. What we've just done here, we created a public string new name. Then we place this name to the function we are calling. We call it function my name. Our name will be copied to the function and to the function itself, and we will print I'm and name. And here it's really important to add a semicolon sign, or our script won't be work. For example, let me show you a wrong way writing a script. You will see that some error that this semicolon sign is expected. So we won't be able to launch our game before we fix it. So first of all, we need to fix it, and then we will be able to run our code. So now everything is fine. No more errors. And here we can see a new variable, new name. We didn't provide any name, so we just printing us again and again, I'm. So if we type my name, I'm Ivan, we'll see I'm Ivan. And if we write any other name, Bob, I'm Bob, will be written. So next, really important thing inside the C# is the conditions statements. For example, if else statements, you might record it in any other languages. C# has them as well. So it also can be used for any other different purposes. Like, for example, we can write any condition. For example, if someone inside the room, we can turn on the light. And if someone left room, we turn off the light, and so on. Let's create a new variable, public int score equal to 60. And write some function. For example, if our score equal to 60, and next condition, we can print fast. If we're talking about exam. Yeah, let's provide some other example, 40 in the beginning, default value, and move to the Unity. So now we have 40, it won't print anything. Let's clear it, and it's not printing anything because condition is not satisfied. Only if score is equal to 60, it will print us fast. If we set 50 here, no luck. And if we past 60, it will print us fast. So here we go. Next, we can write more complex conditions. For example, if score is bigger than 60, we print fast. And in another way, if it's not bigger than 60, for this we need to use else. Else print. We can print try again. So we save it and go to the Unity. So if it's bigger than 60, it will print us. And if it's smaller than 60, it will print us try again. And there are also more complex conditions. For example, if we need to write multiple conditions, we can use else if statements. For example, if score bigger than 60 and score smaller than 75, we write fast, not bad. Else if another condition score bigger than 75, smaller than 95, for example, 100. And we can write this condition again and again. For example, else if score is equal to 100, here we can past well, here past great. Else try again. Let's check it again. In the beginning, we check the square or past not bad. If it's bigger than 60, smaller than 75, it will write this condition. If it's not satisfied, if for example it's 80, the next conditions will be checked. And so if it's 80, it will print as passed well. And in that case, other conditions already won't be executed because we have this condition satisfied. So let's check program in the Unity. Now we have 40, so we should try again. If we have bigger than 60 but smaller than 75, it will print as passed, not bad. In case with the 80, passed well, and if it will be 100, passed great. So that's all what about these conditions with the integer numbers. But the interesting thing is that we can also work with the conditions, not only with the numbers, but also with the string data, for example. Let me delete this one. And let's check conditions for the name, for example. We check if I'm Ivan, for example. We take our string value and compare it. Equal to, for the equal, you need to use double. Fine. Ivan. Print you are Ivan. Else, print you are not Ivan. Okay, let's check. Go to the Unity. Run the game. Currently it's printed as you are not Ivan because your name is not provided. Once I write here Ivan, will print as you are Ivan because condition satisfied it. And if I write any other name, Bob, will print as you are not Ivan. So that's for the string data. Also, conditions can be worked with the Boolean data, and it's more interesting case. For example, let's create new public variable, bool, student, by default, and by default it will be false. Bool data, it only has false and true condition. So let's check if the student will be true. We'll print that student passed. Student equal to true, passed. Go to the Unity. Inside Unity, you can see that we create new student bool data, and it's shown like this toggle. You can click it, and this sign shows it's true, and if it's unsigned, it's false. So if we run condition, run game, we will see nothing here because it's false by default. And if it will be true, we will see passed. Okay, let's check it, and it will print us passed. With a Boolean data, it's not necessary to write this equality sign. We can simply write it this way, but it works only for the Boolean data, which has true and false condition. So this statement means similar to student equal to true. They're the same. And if we go here, we will see that we can also will obtain the same result. We check it as true. It will print us best. And another interesting way of working with the Boolean data that we can check conditions. We can check inverse condition. For example, if we add exclamation mark, we will check on false statement. Here we can write false data. Now we are checking for the false. Here also change it to the true by default. Oh, and here we'll change it. Try again. Now, if condition is false, it will print us try again. And we are checking false condition again. Like, pay attention as we're using this exclamation mark here. So let's save it. Go to the Unity. Clear it. Now it's true, so it doesn't print us anything. And once it will be false, it will print us try again. So let's uncheck it. It will print us try again. So once we work with our script, and for example, if we finish our work and we need to go to the fork, and we will see any changes here. So we created new script. We can also upload it to the GitHub page online. First of all, we stage it, then we commit subject, our first program, and commit for files. Without these descriptions, we can't commit it, so we need to write it. Commit, or commit. Oh my God, we almost finished. And push it to the server. So now our changes will be online here. Our first program 20 seconds ago. So now one more time, I'd like to pay your attention to your homework. You need to install Unity with the Visual Studio, create a GitHub account, install fork. And on practical class, we'll try to program things I described to you today.